This is lesson 6 of Unit 9. In this lesson, we will take a look at what's called the activity series. Now, the activity series actually predicts single replacement reactions. So in the last video, we talked about double replacement reactions. In this video, we'll talk about single replacement reactions. So the activity series is a list of periodic table metals in order of reactivity, or in order of activity. And it predicts which single replacement reactions will occur. So here's how it works. A metal listed above it is more active, so it will replace a metal listed below it in a compound. So the metal below, because it's less active, will end up alone, because the series lists the metals in order of activity. This will make more sense when we try a few examples. So here is the sample activity series. And the whole activity series is not represented, but this is good enough for us. What we do is we list the metals from top to bottom in order of activity. So lithium is the most active. And as we go down and go down here, we get down to gold, which is the least active. You may recall that gold is what's called a noble metal, along with platinum, actually. Platinum is another noble metal, because they are not reactive. And you know that lithium, rubidium, these are group 1 alkali metals, are very reactive. In fact, if you throw them into water, they'll cause quite a bit of a ruckus. So what you see here roughly is these right here are the S block, which are very reactive. S block are very reactive elements. These here are roughly the D block, so the D block. And these here are also in the D block, but they can be called the noble metals. So you don't have to memorize the activity series, but the general version of it is this. Now you can also have an activity series of the nonmetals, and that's what we have on the right side here. And the nonmetals really just involve the group 17 elements. Remember, these are the halogens. And it's interesting that their activity is in order of how they appear on the periodic table. So fluorine's on top, and then chlorine, bromine, iodine. Fluorine is the most reactive, and we actually talked about fluorine being one of the most reactive elements on the periodic table, at least as a nonmetal. And iodine is the least reactive. All of these are reactive, but reactivity here decreases as you go down, is the idea. Okay, now we're going to use this activity series to predict single replacement reactions. And how will we do it? Like this. The top metal is the more reactive metal, and so it will replace a bottom metal, which is the less reactive metal. So if we were to put potassium against calcium, what will happen is that calcium will end up alone, because it's the less reactive. It'll be the one that's by itself. That's kind of like the noble metal or noble gas that's unreactive. So in this case, calcium, K, will react and end up with the compound, as you'll see. So we're going to try a few of these. So here's the, there are 4 of these that we're asked to try. In fact, the very first one is the one we've been talking about. So we have potassium. Now, since all of these are single replacement reactions, what you're thinking about is calcium replacing the other metal in this compound. And then potassium will be by itself, essentially. Before we can do this, however, we have to think about, is potassium or is calcium more active? Now, looking at the activity series, we just saw that calcium is at the bottom, so calcium is less active. So in fact, this reaction here will not happen. Potassium is more active, so it will remain with the nitrate. Calcium is less active, it will not react with the nitrate. So in this case, we actually have no reaction. And it's possible for you to have no reaction. All right, how about the second equation? Here we have zinc against strontium. Against strontium, we'll try to replace zinc. We have to first look who is more active. If you take a look at the activity series, you'll find that strontium is sitting above zinc. So strontium will be able to replace zinc, because strontium is an S block metal and zinc is a D block metal. You can think of it that way. So the product will be between strontium and chlorine. So we'll put strontium chloride. Now when you put strontium chloride, you have to again think about balancing the charges. So Strontium has a +2 charge. Chlorine has a -1 charge. You need 2 chlorines for every strontium. You must put SrCl2 for the product. The other product then will be zinc, like so. Now for the state symbols, what you'll see is that the metal by itself will be metallic, and so will this one. The other one will be usually aqueous. So for our purposes, we could probably put aqueous for the other one, and that should work. Okay, let's clean it up a bit, and let's try the next one here. We have iron going a bit up against cobalt. Now if you take a look at the activity series, let's go ahead and think about who is more active. So take a look at the activity series. Is iron or is cobalt above? You can see that the iron is slightly above cobalt. So since iron is more active than cobalt, again, there will be no reaction here. No reaction. So what we're introducing to you here is the concept that not every 2 chemicals that you put together will react. And this is logical. Not everything reacts. And this allows us to predict a little bit of which react, which don't react. So no reaction because cobalt is less active than iron. So cobalt will want to be by itself, is the idea. Okay, and then this last one, we have KBr against Cl2. Now, in this case, you actually have a nonmetal. Chlorine is a nonmetal. So when chlorine tries to replace something, it will replace a similar element. It will replace this nonmetal, bromine. Then bromine will take the place of chlorine. Before this happens, we have to predict, is chlorine more active than bromine? Looking at the activity series, chlorine is above, so this will happen. So chlorine will come in and replace the bromine. So you'll end up with potassium and chlorine, potassium chloride. In this case, K is +1, chlorine is -1, so they match up perfectly. And your other product will be bromine, which will be by itself. Now recall that bromine is one of those diatomic elements, so you have to put a 2 down at the bottom. So KCl plus Br2 would be the products. In this case, again, you can put state symbols. Bromine, if you recall, is actually a liquid. It's the second liquid on the periodic table. And the rest of these we can put as aqueous, in our case. Okay, so hopefully this makes sense. Go ahead and try, as you've always done, one of these on your own, this problem, and we will practice a lot of these in class. So this completes for us lesson 6 of Unit 9.